So here we have Olsen Company. Their capital structure consists of 50% equity, 50% debt. They're trying to do some kind of expansion, and they need $4 million. So we're trying to compute WACC. If we skip down to the bottom of the problem, that's what we're trying to compute. So they need to raise $4 million, and they have $1 million worth of retained earnings that they can use at 11%. So we'll start our WACC equation, right? So WACC is the weighted average cost of capital. So far they got $1 million at 11%. We have to calculate the weighted average of that $1 million that we're going to use to get our $4 million, right? So $1 million out of $4 million, we'll just do an equation that's equal to 25%. So 25% of our investment is going to come from retained earnings at 11%. So over here, I'm going to put equals, say 11%, right? So this is, we'll just call this retained earnings. What am I trying to do? Retained earnings, boom. There it is. Now we've got next what we can use. The Olsen Outfitters Incorporated company has common stock, and they have $8 million that they can issue in common stock at 13%. So we'll just say common stock. Okay, common stock. Let's make this a nice, pretty color. Common stock. They have 8 million. We only need 2 million out of that 8 million because retained earnings and common stock are both equity, and we can only use 50% of it because that's what our capital structure consists of, 50% equity. So we already got $1 million from retained earnings. Now we need 1 million out of this 8 million at 13% to get our $4 million investment. So 1 million out of that 8 million. So 1 million out of 4 million. We got to calculate our weighted average. That's equal to 25%. 1 million out of 8 million. At our 13% cost. So this is going to equal 13%. So far we got $1 million in retained earnings at 11%, $1 million common stock at 13%. That does it for our equity. So I'm gonna turn this a bright ass color, yellow. That's our threshold. This is, I'm gonna say, equity. We'll just turn that green. I like green. All right. So now we have our debt. I'm going to say debt. That's going to compose our other 50%, right? That's going to give us another 2 million. So our debt, let's see. So what do we have? For debt, Olsen Inc. can raise up to $4 million at 11%, right? So out of that 4 million, we only need 2 million because remember we got $1 million from retained earnings and we got $1 million worth of common stock. So now, hell, we only need $2 million. So that's what we're gonna do. We're gonna take 2 million out of that 4 million that we can use at 11%. So if we take $2 million and we get our weighted average from the $4 million that we need altogether, that will give us 2 million divided by 4 million should be half, right? So that's our weighted average of the debt, 2 out of 4 million. We can borrow it at a percentage of 11%. And remember, when we're dealing with debt, we have to account for the amount that we're actually gonna be kind of spending in debt. So we get a tax deduction for using debt. Remember, companies can deduct interest payments, right? So this is saying, the problem is saying the company has an effective tax rate of 40%. So we have to multiply our weighted average for the debt times the cost of debt times 1 minus tax rate, right? So 1 minus tax rate, which is effectively, and the tax rate is 40%, so it's going to be 60%, right? So this is going to be equal to 1 minus, what is that, 0.40, 60%, okay? So now, all this shit here is going to be, well, debt, I already got it up here. So now we can calculate our weighted average. So I'm going to start our formula here, equal to the weighted average of retained earnings times the cost of retained earnings, right? Plus weighted average of common stock times the cost of the common stock, right? Plus weighted average of our debt times the cost of the debt times the amount that we're actually going to be charged, which is 1 minus the tax rate. I know that's probably not grammatically correct, but who cares, right? So now, if I hit enter, it gives us 0.093. And if we change this around, we can turn it into a percentage. Of 9.3%, and this is our answer.